What's up, guys? Welcome back to the GSP YouTube channel. Today is going to be a good one. We have new toys. Check this out. Oh, straight from Mama Holley herself, we have our glorious, unassuming white cake box with all sorts of goodies inside. I literally have not cut the tape on this. I have not been inside of this. You are going to see this with me for the very first time. And I'm really excited because this is going to give me the opportunity to go through and install and give you guys some awesome content along the way. And I'm going to cover a bunch of stuff just right out of the gate tonight when you open your boxes for the first time and get your kit. So I'm going to really quickly describe what I have here. This is a kit for a 58X wheel, 4X camshaft obviously, and it's for EV1 injectors because that's the injector that I have to use. Typically your 58 stuff's going to come with an EV6 injector, but it's just completely dependent upon what injector you're going to use. I have some adapters that I'm going to try as well that go from EV6 to EV1, and I'm going to show you guys some cool stuff about how I think I've got some data that proves that a larger injector is going to make more power for the same given power level. I'm going to try to do some of that, but this is later on. So again, 58X, 4X, EV1, and this is a max because I need to drive by wire, being a 58X vehicle. This is for the silver Corvette that you guys have seen in a lot of my videos, and mainly the gender reveal burnout video. Yes, to everyone's surprise, that is in fact the factory controller tuned by yours truly using HP tuners. It's an E38 if anybody's familiar with it. And while the E38 is an extremely capable ECU, it is still handicapped by all of the same things that handicap any of your OE computers. They are designed for fuel mileage and occasionally get taken to wide open throttle. And Holley setups are designed to give you complete control of every situation with your engine. And so I'm really excited to try this out, and there might be a little something extra coming as well that I needed the Holley for. So let's get started in this, see what we got. Surely I can get into a box fairly quickly. Alright, first things first, we got our main power harness. So, just to cover a couple of things about the main power harness. If you read the instructions, you'll see that it says to connect this thing directly to the battery. And I cannot, oh, it even says it on it. It says it right here, directly to the battery. I cannot stress to you guys enough that when you hook these things up, I see this get asked on the forum all the time. Can I hook this thing near my battery? Can I hook this thing to a fuse block? Can I hook this thing to whatever? No. Connect it directly to the battery. And the reason is because the battery is a buffer. The battery is like a surge tank for your electrical system. If any of you are familiar with the way that your well works in your house, if you're not on city water and you're on well, it gives it a large volume so that small changes in pressure even out over that volume to not cause any kind of rapid changes in pressure inside of your house. It makes your living experience nicer because your water pressure doesn't surge, it doesn't dip out and come back when the pump goes on and off. It's the same thing here whenever you're feeding your Holley. Your alternator is constantly adjusting based on the load. And so if you hooked this thing to the back of your alternator, holy cow, if you hook this thing to the back of your alternator or to your fuse block or something, anytime those places in your electrical system see a change in voltage, the Holley is going to see a change in voltage. And it may not be necessarily, if you quote unquote real, it will affect calculations, not to mention could potentially hurt the ECU if it gets a big spike that otherwise the battery will take out. So connect this directly to your battery. Holley is very generous with this cable and makes it plenty long enough for you to mount this on a remote mounted battery that's in the trunk. Really no excuse. They give you nice ring internals that come with it. connect this to the battery. If you have to extend this, it's okay. Just do a really, really good job of extending these wires with good uninsulated crimps, and use glue-lined heat shrink, and make a really good connection here. It's really important that this has got a good connection. Additionally, your battery switches, you know, sometimes you have a battery shut-off switch. This still goes directly to the battery, and the reason is because your battery shut-off switch is going to catch the 12-volt wire that goes in the harness to key on the ECU. But if this loses power while the engine is running, if you're taking a data log, it's gone. It's lost. This is the thing. If this is still on and you cut the power off and this still has power, it says, okay, he wants to stop the data log clearly because he just shut the engine off, and it will go ahead and save that data log for you. So make sure this goes directly to the battery. All right, next thing up. It looks like it's going to be the main harness. Yes, it is. So this is obviously the main harness. This is going to go to your engine to run the injectors, the coil packs. It's going to pick up cam and crank, coolant temp sensor, oil pressure, fuel pressure, all that jazz. I'm going to set this aside because I'm going to go through it very, very finely here in just a minute, but I want to go ahead and get everything unboxed so you know what you're looking at. I'm going to set this here. Looks like we got our 3.5-inch handheld. This is cool. Handheld comes with a stylus and a screen wipe. It's in here as well. Cool part about the handheld. So with the handheld, you get your SD card that is right here in the back. Terminator X systems do not have a onboard storage. The way that they save data logs, the way that they store tunes, it's all done on that little SD card. If you do have a 7-inch dash or a Pro Dash or any of the Holley add-ons, you can data log internally with those devices. But if you don't have that, this guy right here is going to be your life when it comes to data logging, unless you're driving around with your laptop in the seat beside of you. Typically, I don't mind riding around with a laptop, but what I will tell you is that as you start going faster and faster and faster, you start running into situations where that laptop wants to vacate whenever you let off the trans brake button, or whenever you dump the clutch. And same thing whenever you go ahead and say you grab a parachute, then the laptop tries to go through the firewall. Thankfully, I haven't had any catastrophic failures from that, but we've moved the laptop around, let's put it that way. And when you got a USB cord hanging out of that thing, that's no fun. Next thing, the injector harness like we talked about. So these things are actually pretty expensive if you went to go buy this separately. This is, like I said, an EV1 injector harness. And I thought about trying to get a spare injector harness to run EV6 injectors, because the factory injectors on the car are still in place. They're 42 pounds per hour, and they are EV6. I'm gonna try the adapters first. I'm with it with you guys on a lot of this stuff. I don't really love the adapters. That said, I've also never had any problems with them. So it's kind of more of a directionally correct thing. In theory, I don't love having yet another plug attached to this. I'll go ahead and grab this out of the bag. But in all reality, it's kind of maybe not a big deal. We'll find out. I'm gonna play with it. I'm gonna go both directions with it. I've got 2 sets of adapters. One to go from EV1 to EV6, and then the other one is to go from the EV6 harness on the factory controller to the EV1 injector, and that's going to lead me into my next little teaser real quick. The plan right now, I'm not making promises yet, but the plan right now is I want to put the car on the dyno, and I want to make a pull or 3 for averaging with the factory ECU, and then I want to unplug the coil pack harness, and I want to unplug the injectors, and I want to unplug the throttle body and plug the factory controller the Holley controller right into this thing on the dyno. Engine's still hot, 2 minutes apart, however long it takes me to swap it over, and make a back-to-back pull, and then we will compare the data. We'll look at the differences that it made. We'll do the same thing with the injectors. I want to swap injectors and see if it makes any difference. I have my own theories, and I'm willing to, if there's enough interest, I'm willing to go into the theory side of things before we go to the dyno and test this, because I'm not trying to hide anything. I have no vested interest in either direction here. This is my kit that I purchased solely for myself. I spent my own money on this. Nobody gave this to me, and we'll see what it does. I'm really excited to do some A/B and probably back to A testing. A lot of times people don't close the loop on it when it's too difficult to swap back and verify that your initial results were valid. You need to be able to go back the other way and close that loop. So anyway, let's set this over here. Oh boy. This little problem child right here. The old Bosch 4.9. So this thing is the thorn in a lot of people's side, and I want to just touch on it that this thing is just like any other sensor. It is only as good as the data that you are providing it, and so I've kind of touched on this in one of my previous videos about how-tos of EFI and everything, and things you need to know about EFI. The thing about the oxygen sensor is, and the vet is going to be an extremely good example to show you guys this. It's gonna be awesome. I'm really excited about it. I currently have 2 of these. I have 2 Bosch 4.9s in the vet that are currently wired to run the factory narrowbands, and that's one thing that's really cool. And I'll give a quick plug, shameless plug to a product that I have used a lot. 14.7.com, 14point7.com. It's a guy out of Canada. I don't know the guy at all. I've purchased 3 or 4 of his widebands from him. He makes an awesome, easy to install, great packaging, quick, easy solution to run a wideband on a standalone application for a wideband. He uses the 4.9. He's actually got some later model stuff that's out too that I haven't gotten to mess with yet. But one of the things that he provides in his wideband is a narrowband output, and it'll simulate a narrowband based on what the wideband is doing. And I gotta tell you, that narrowband output signal is substantially cleaner, sharper, better, I don't know what you want to call it, than a true factory narrowband sensor. The narrowband sensor it switches, and it's this nice shark tooth pattern. Kind of has a mind of its own. It might kind of switch and it might not. These guys, whenever you use them in a narrowband application to run your OE stuff, if that's what you're doing, is awesome. Yes, this is a Holley video, but information is information, and I have no problem talking to you guys about OE stuff if anybody's interested in it. I cut my teeth on the OE stuff, been tuning that for about 8 or 10 years, and the Holley stuff in the past 2 or 3. Holley's way better, don't get me wrong. I'd rather tune Holley from now on. If I never had to open HP tuners ever again, that would be fine. But that said, doing this piggyback install on the vet, and this is going to have to be a piggyback because that thing uses the computer to open the doors. It uses the computer to run the lights, and the dash is CAN based. It's very computer heavy, so I'm going to have to piggyback it. It's a push button start. So the ECU is going to have to see that, and that's part of what this whole video series is going to be, is installing this in a piggyback fashion. And I'm going to do everything in my power. I'm going to try my hardest to not cut either of these harnesses. I want to be able to plug one of these into the other and very simply be able to unplug it and put the factory ECU tune back in it and drive away. I'm going to try to do that. I'm not making the promise yet because although I've looked at the wiring diagrams and I've laid it all out, and it's going to be a little bit of an undertaking. And anyway, long story short, we'll have to make sure that I can do that before I go telling you that it's going to happen. Back to O2s real quick. These guys are only as good as the data that you give them, and talking about the vet being a great candidate to show The larger the camshaft is, the more overlap you have at idle. Well, you have the overlap all the time, but at idle is when it really, it shows up and gives you a hard time. What happens is there's a lot of natural reversion and a lot of crosstalk between the intake valve and the exhaust valve whenever there's this overlap period and the piston is traveling really slowly. You'll take in fresh air and it will go right in the intake valve into the combustion chamber, into the cylinder, and right back out the exhaust. And then the natural EGR effect, the exhaust gas that was in there that didn't make it out, it just stays in there and doesn't burn. And that's actually why a cam sounds the way that a cam sounds, is that it's basically an engineered misfire that is trading off on multiple cylinders, one after the other. And anyway, long story short, that extra oxygen that goes through the exhaust valve makes it to your oxygen sensor, and it will force a condition that shows lean that's not real. And you'll find that any EFI system, this is not the fault of Holley or the factory ECU or anybody. It's going to cause the car to push rich, and so you'll end up with a very rich idle that is continuously getting richer to a point that it starts to finally average out and level off. But if you're showing 14.7 on the gauge, that might end up being more like 10-1 or something crazy. I mean, it's bad enough that it'll end up fouling your plugs out, and it'll make the car just flat out not run after a while. And so anyway, there's ways around that, obviously. It's much easier to handle with Holley than it is with the factory ECU. That's part of one of the reasons why I'm going to the Holley setup, is because we can command when to turn closed loop on and off, right? We can tell it to limit it by a percentage. That's one way to do it. We can do it by coolant temp, which is not going to help the situation at idle. We can do it by TPS and by RPM, which will help the situation at idle. Currently, the way that I've gotten around this in my E38 factory ECU is to force the E38 into power enrichment mode. And I don't want to get down that path in this video, but long story short, I'm idling an open loop and just completely tuning it by ear. And yeah, that's why I have the Holley now, because I don't want to have to do that. I'm defeating the purpose of having my EFI. It's basically a glorified carburetor at that point. It's just delivering the amount of fuel that I tell it to deliver. At least I can control it based on manifold pressure and manifold temp and coolant temp and all that stuff. But enough about O2s, but I'm going to do a video on these guys alone at some point that's going to cover a lot of what I just said, and then also a whole lot more. Placement of these things is extremely, extremely, extremely important. Exhaust systems, the way that they run, is extremely important. So we'll talk about this. I've already covered, do you need 2 of them, or 8 of them, or 16 of them, or as many as you want. If you are interested in that, go back and check out my video on things that you need to know about EFI. All right, more rambling. Here we've got the I/O harness. So this trips up a lot of people. That's surprising that they get this, this harness in the kit, and then they wonder, where on earth does this go? It's got a bunch of wires. What do I do with the wires? I/O stands for inputs and outputs, and your I/O is what you're going to use to do things like run your cooling fans. Air conditioning is something that comes preloaded in the Wizard tunes on a certain set of wires. There's 4 inputs and 4 outputs. The white wires with the colored stripe are your inputs. The gray wires with the colored stripe are your outputs. And I also talked about this in that same how-to video, the EFI video, the difference between an input and an output. Really quickly, an input means you want to tell the ECU something. You want to tell it, I pushed the button. You want to tell it, what some sensor that is not included in this setup, what its value is. Anything you want to tell the ECU is going to be on an input. if you want the ECU to make a decision based on something else, then you got to give it the input. Inputs for turbo setups are going to be your map, basically your dome pressure on top of your wastegate, and in the case of like nitrous, for instance, you could actually do a fuel percent offset based on bottle pressure. You could tell the ECU the bottle pressure and automatically correct for that. Different things like that. Outputs are going to be things like actually tripping the relay to run the fan, tripping the relay to shut off your AC. Those come preloaded in the Wizard. Running your solid state relay for your nitrous solenoid. Running your MAC valve for your boost setup so that you can make more boost. That's going to be something that the ECU does for you. That's an output. This thing goes on this main harness. See if I can find it in here. I'm gonna come back. I'm gonna circle back around and take this harness loose so we can actually lay it all out once I clear off the table. This guy right here is your wideband adapter. A lot of people are wondering why on earth you need a wideband adapter. It's real simple. These things right here is not something that Holley makes. This is a Bosch thing. This is a Holley connector. So this goes on that. This right here plugs into the harness here. I go shopping for it again. There it is right there. Bam. Wideband O2 is connected. So that's going to go in your harness. And this ends up giving you a pretty decent lead. You can run this wherever you need to run it. So, all right. Next thing, what else we got in here? O2 bung and different adapters for your internal map sensor. I'll show you guys that when I get the ECU out in just a second. I'm betting this is my drive-by-wire setup. Let's see here. Terminator X Max ECU. Ooh, maybe this is the ECU. All right. Okay. Looks like this is the ECU. Oh yeah. All right, let's talk about this really fast. So, this is the little internal map sensor I was talking to you guys about. One thing you need to know is whenever you first set up a Wizard tune, and I don't recommend that. I think you should shoot me a PM or call me or something before you set this up. You should not have to use a Wizard tune. But when you set up a Wizard tune, it defaults to the internal map if you choose a 1-bar. If you choose a 2 or 3 or 4 or 5 whatever bar sensor on the engine, it will ignore this. But if you choose 1 bar, it's going to go to this, and you have to go in the laptop and change that if you want to use the actual onboard map sensor that's included in this harness here. I don't really like that, but it just kind of is what it is. There's nothing really I can do about it. You got your J1A, J1B inputs here. These are your standard, ins and outs. These connectors right here. And the rest of this is for your drive-by-wire and transmission control. Obviously, we got the LEDs on the front here. Because we can't do a system log with a Terminator, at least I haven't figured out how to do it yet. You got to have the LEDs to figure out what you're missing if you do have a problem. They are kind of helpful. I'll admit it that I had a couple of cases where I was able to help some guys out that, which light's red, which light's green, which light's blue, do they cycle, all that stuff. So they're good to have. Holley wants you to mount this in a location such that the ECU is facing this way, that it's, your connectors are down and the lights are up and the X-Max reads up. So no big deal. There's a little port in here too. You probably can't see it on the camera. That the ECU actually has an onboard baro sensor, which is kind of cool. That's something that you don't really get with the with the OE computers. The way they do baro correction is they look at it. Sometimes whenever the key on happens before the engine starts, and then other times they'll do it at wide open throttle. If it ever sees a wide open throttle event, it'll do a baro correction. So it's just cool that it's on board. You know, you can really quickly and easily scale your map sensor if you need to for your elevation. Just a good gut check. So set that over here. All right, last thing. This has got to be the drive-by-wire setup, and obviously we have our wonderful manuals as well. I'm gonna go ahead and set this down. So let's see what's in here. Get my knife back. All right. Sure enough. So let's talk about this really fast. It says it all over it. It says it in the instructions. It's got really big red letters. It says do not cut or modify, and I have to tend to agree with Holley on this deal. The problem that you have when you start cutting and slicing is if you make a bad connection here and it changes the voltage in the line, because that's what we're working off here. We're working off of a 0 to 5 volt reference. The way that this system works is it takes the pedal position, and there's redundant sensors in the pedal. It takes the pedal position and it tells the ECU, I'm seeing 10% on the pedal. And the ECU looks at a lookup table and says, okay, well, when I see 10% on the pedal, my throttle body blade, my TPS percentage at the throttle body, I want that to be 15%. And it's usually some kind of offset in that realm, because you need some amount of throttle at idle in order to establish enough air to run, because the drive-by-wire setups don't have any kind of idle air control valve. All the air that enters your engine, unless you have a vacuum leak, is going to enter through the throttle body. So the way that this works is it's a simple PID loop, and I know I keep referring to that, and I do need to make a video on PID, but basically, long story short, it's a simple ECU program to run closed loop. It says, all right, I'm at 14, I need to be at 15, I'm going to make an adjustment. And then it says, oh, well, I'm at 16 now, and I've gone too far, I'm going to make another adjustment. And it's constantly chasing having the throttle body in exactly the right place. So the problem comes in if you go cut this thing and you modify it and you don't get the shielding hooked up just right, and you get a lot of interference, or say you put bad crimps in and those voltages are not stable, you potentially could have a hung throttle. It's a really actually fairly dangerous scenario if it's not done properly. And so Holley says don't cut it or modify it. I'm gonna say don't cut it or modify it unless you absolutely have to. And if you do, holy cow, be careful. It's really important. One other thing I do want to touch on for all my drive-by-wire guys, there's this red wire right here. It's red with a white stripe. And what this is for is a runaway situation. The way that this works, if I can get this out of here, is you wire this so that it sees, basically anytime your brake lights come on, it sees 12 volts. So like if whatever sensor is on your brake pedal, this wire goes to it, and whenever you press the brakes, or even your brake lights, the reason that Holley did this way is to go on some really old cars that didn't have any kind of brake sensor. You literally can wire this into the 12 volt circuit on your brake lights. The way that it works, when this sees 12 volts, Holley says no more than 20% throttle. And the reason that it does that is because they don't want you to get into a situation where, say it did fail for some reason and the throttle is now hung wide open and you have an automatic and you cannot stop, and if you hit the brakes and this wire is not attached, obviously it's not going to know you're hitting the brakes, and it's just going to stay wide open, and you're going to have to come up with something else, flick the key off, whatever you got to do, push it into neutral somehow. That's a bad scenario. That said, there's a real problem. You can't do a brake stand. You can't do a burnout. if this wire is attached. It'll load up and not go any farther than 20% throttle. And the reason that it's 20% and not 0 or 10 or whatever is it's a limp home thing. So if your brake lights get stuck on, then, you know, obviously if my brake lights ever got stuck on and I had this attached, I'd pull over and clip this thing and go home. Maybe I shouldn't say that. Don't do that. That said, it's a safety feature. I'm probably not going to run it like most anybody that installs this kit. You know, I don't want to say that I'm sitting here telling you to, you know, do something unsafe. That's not what I'm getting at all. But this thing kind of limits you, and in a drag racing application where you need to, you know, do a burnout, you need to grab the brakes, especially in my case where I got a stick car and I need to, you know, kick the clutch, grab the brakes, and do a nice big smoky burnout. This thing is not going to let me do that, so we're going to have to come up with something else on that. As far as the connectors go, this obviously is the connector that goes to the ECU, and this is going to be your throttle pedal, this is going to be your throttle body, and it very simply has got a 5-volt reference and a ground, sensor ground, and you have 2 TPS sensors in both of those. It's a redundant system and they're inverted. It's meant to be whenever it sees any kind of error, if they don't match up, it goes, nope, fault, I don't agree, and you need to work on your setup because something's wrong. The throttle body dies or pedal dies, anything like that. Okay, enough on that. My plan is I'm going to try to make adapters so that I can double these up and be able to feed the factory ECU and also feed this, because I don't really want to have a reduced engine power light in my Corvette, and I don't want to have a check engine light or any of that stuff. So I'm actually going to try to feed the factory ECU all the inputs that it needs. It'll never know that it's not actually controlling the fuel and spark and throttle position. So I'll keep you guys posted on that. It's going to be interesting. I think what I'm going to try, and you guys tell me if you've done this and I'm like out to lunch here, but I think what I'm going to try is, instead of feeding it the pedal position and then feeding it the throttle body position, because they're not going to match up, you can set this table in the Holley to do whatever you want to do. And while it is you can change it in the E38. A lot of times, if it doesn't like the curve that you put in, it just goes into reduced engine power mode and doesn't run. I've tried that. It's kind of finicky. I think what I'm going to try to do is just feed the pedal position to both the pedal position on the E38 and also the throttle body position on the E38. And it might be a little bit angry with that because it's going to expect to see about a 20% offset, but I'm just going to see how it goes. I'm going to see what I can pull off there. But all right, enough of drive-by-wire. So we got drive-by-wire covered. We've got our wideband covered. We've got the I/O harness, and I'm going to actually leave it out for just a minute. The handheld device for the SD card and the data transfers, and our main power harness that goes to the battery, the injector harness for EV1s. I want to say these things are about $100 to $130 if I'm not mistaken. And I was going to get a second one of these because it was a much cleaner way to attach EV6s. But honestly, the little adapters that I got off of Amazon were like $12 or something, so it kind of didn't make any sense. All right, let's roll this guy out because I want to show you guys some stuff. So we'll get the zip ties off here, the thread ties. And they tied it up good. They knew I was going to make a video and I was going to have to keep talking and not have any music or anything, so it gets nice and boring while I'm sitting here working on this thing. All right, one of them is off. I'll go ahead and grab the other one over here. All right. we're going to start at the ECU right here. So these are your two J1A, J1B connectors. And the way that these work is, I'm not gonna say 100%, but most of these are either ins or outs. These are gonna be your outs, these are gonna be your ins. And the reason that I know that is because I can see the 5-volt reference wire coming in, and that is definitely gonna be an out. So anyway, these go to your ECU, make sure that they're plugged in well and they clip in good. When you're inspecting your harness, make sure you look inside and make sure that all the pins are seated really well and you don't see any exposed wire anywhere. And I may or may not put it on video, but I'm gonna go through and check this harness. You know, I see a lot of times you guys have trouble with their harnesses, and I know Holley is doing the best they can, and they've offered a really good product at a really good price, and you know, they're making a lot of these things and things happen. So it's kind of statistics. Whenever you make more of something, you're going to start having more issues because there's just more opportunities to have a problem. All that said, I'm going to go through it. If you guys want to see me go through this harness, it's going to be brutally boring. But if that's something you really just like want to see me do, I will. I'll make a video on it. Leave me some comments below. Tell me what you think. Next thing up, this relay. So this is the main harness relay. When this runs, it is powered by the ECU, it's controlled by the ECU, and when this is on, your fuel pump run, that's part of your fuel pump prime, and your injectors have power, and your coil packs have power. And these two wires are extremely important for making this work. This red wire with the white stripe is your switch key source. Doesn't really matter where you get that from. I see a lot of people asking, where do I get my key, power? You can get it from anywhere that has a good, solid power source during cranking included, and it cycles with the key. Make sure it's fused. Make sure that if this wire gets damaged in any way, it will blow a fuse and will not just, arc. And at that point, it's probably going to hurt your ECU. And then the other thing is make sure that this ground right here has got a good ground. It's the ground for the relay. And if you don't ground this well, you're going to have issues with your fuel pump coming on and off, and your coil packs coming on and off, and your injectors losing power. And it's like a really good way. Those three things actually sound like a really good way to hurt an engine. So be careful with that. Next thing is just the main harness fuse. Inside of here is a 30 amp that is the power basically for this thing. And so you gotta just be careful with that. If you ever have a situation where you're not getting anything on your relay here, and you can't get anything out of the ECU, be sure to double check this fuse right here, because that could be blown. This little guy, see if you guys can see this little can connection right here. That's for any of your CAN devices. So Holley handheld 3.5 inch, the USB to CAN cable, it's something we got to use to get the laptop to connect to a Terminator X ECU. Your Dakota Digital dashes, Holley dashes, race pack, all this stuff is going to be CAN based. There's a red wire and a black with a yellow stripe that is power and ground. And then there's a high CAN wire that is orange with some color stripe. And then there's another one that is CAN low that's orange with a black stripe. So that's how you do any kind of communication with the ECU outside of the ECU. All right, gonna keep on going here. This is the I/O harness that I was looking for earlier. What's cool about this is, this you have to attach to your car, right? Your ins and outs go through this, and it's unterminated so that you can attach it to something that's on the car. If you ever have to pull the harness out of the car, then what you do, these should have ring terminals on them, or spade connectors, or some kind of connector to be removable. And you unplug these, you unplug your I/O harness, you unplug all the other connections and take off the ring terminals, and you can pull the harness out. And then this gets to stay while you go change to whatever else you got to change it to, different harness altogether. So that's kind of cool. It goes right there. It's pretty obvious too because the wires, they all match up. When you go to plug this in, the wires colors are all the same. So just keep that in mind. Nice fresh install right there. Nice tight install. Okay, next thing. The power tap. This gets so many people. It's awesome. The way that the power tap works, you get 4 things here, and it's not on the wiring diagram. And I don't know why it's not on the wiring diagram. It drives me absolutely crazy that they would put wires that have a connector that comes out and gives people an option to do something, and it's not on the wiring diagram. But what you have is 12 volts on this green wire whenever the fuel pump is running. So it's, anytime the ECU is running, it's not key hot. Keep that in mind. Now it will be hot for 5 seconds or 3 seconds or 2 seconds, whatever your fuel pump prime amount is. And when Holley primes the fuel pump, the way that they do that is just simply turn this relay on. So your fuel pump will be hot then, and your injectors will be hot, your coil packs will be hot, and this wire right here will be hot, this green wire. The orange wire is a 5 volt reference. A lot of our sensors run off of a 5 volt reference, and so you got to have this 5 volt in order to provide a high level for those sensors to run. Right next to it is sensor ground. It's a black wire with a white stripe. It's really important when you're using all your different sensors that I was just talking about that work with the 5 volt. You need to also provide them sensor ground. And the reason is because chassis ground and sensor ground could be actually quite a bit different. Steel is a horrible conductor. If you take a fender washer and stick this sensor that you just connected to this 5 volt reference right here to the frame rail, that's not the same as the same sensor ground that the rest of the ECU is running off of. You've got potentially a volt or 2 worth of offset that it's just going to wreak havoc for that whatever sensor it is that you installed. It's not going to read correctly. You're going to have to have some kind of weird scale that it may not be linear. It just don't do that. Use the sensor ground. Holley gave it to you right here. And lastly is just going to be a chassis ground. If you do need to actually use that to run, if you power something with this 12 volt, then you have the chassis ground that you can also use to give it a ground. It comes with this plugged connector. If you order the correct pins, it's a MetroPack style connector. If you order the correct pins, you could use this right here to create your own little harness to plug in and run whatever you need to run. And again, just like the I/O harness, you would be able to go around and unplug your harness and continue on. So, all right, next stuff up. This blue wire with a white stripe right here is your TAC output. So Holley gives us a square wave TAC output that we can feed a shift light or a tachometer on the dash. Any of your autometers type stuff is what that's going to be for. This green wire is going to be your fuel pump out, and then this red wire right here is fused hot. So the fuel pump out, let me talk about that really quick. It states that you can run, I think it's don't quote me on this, I think it's a 14 amp pump off of this wire. Don't do that. Just don't do it. You'll never, if you run a relay off of this wire, you'll never have to worry about, am I over, am I getting full voltage on my pump, am I going to backfeed and hurt something somewhere? Just don't do it. It's that simple. Run a relay. It's a really simple 4-pin relay. You run a nice fused large gauge power wire into one side of the relay, nice fused large gauge power wire out. It's the same one, so that's why it's still fused. To the fuel pump, run a ground to one side of the switching circuit on the relay, and run this to the other side. It's 12 volts that comes out of this, and it'll switch the relay, and you can run your fuel pump. And if you decide down the road that you want to run 2 fuel pumps off of the same circuit, then it's fine, because you already have this huge gauge wire that you don't have to worry about, and you don't have to rewire the whole car. All right, now we get the fun stuff. So the cylinder head grounds are probably, all the grounds are important, but if you had to pick one, this is probably one of the most important. There's two of them. You'll see those both here, and they are quite near your coil pack connectors. This is the fuel injector connector, and this is a coil pack with a ground and a coil pack with a ground, and they're the grounds for the coil packs. That's the reason that they're that close. And if you don't properly ground this, and even sometimes if you do properly ground this, you have to re-ground this because it's incredibly important. If you don't have a good ground on this, you cannot charge the coil. If you can't charge the coil, you can't fire the coil, therefore no spark, no run. That's a huge issue. These should be cleaned up, the back of the head should be cleaned up, and they should be nice and tight with some dielectric grease or something on them. This guy here is for your map sensor. This is typically not used if you are using it's definitely not used if you're using the internal one bar. But if you do connect a GM style on the back of the manifold map sensor, or in my case is actually on the front of the manifold because it's a later model Gen 4 style, that's what this is for. Kind of missed it because it was tucked away here, but there is a oil pressure connection back here. The ECU doesn't make any decisions based on oil pressure unless you tell it to in an advanced table, but it is there. And then there's these guys, they're all foiled up. So we've got our crankshaft sensor right here. Obviously they know there's a lot of heat going on around there. We've got a connection for a knock sensor. I did a quick video on the Facebook page about a knock sensor connection. I'll probably hook these up just to monitor it, but I think I kind of covered it. By the time, if you got a high horsepower car, especially if it's something like turboed or nitrous or something, by the time you detect knock, my favorite joke is by the time you see knock, your pistons are in the windshield of the guy behind you, and it's kind of holds true. I hate it, but once you get to the point where this thing says, "Oh, that's not good," it's really not good. It's already happened. It's over and done with. That's also what this guy is right here. They both go very near the headers down at the bottom side of the engine on a Gen 4 engine, so that's why that's there. Another coil pack connection, kind of alluded to, and then there's this nice big harness here. And so we got a fuel pressure that Holley gives us. This is something that's really cool that the OEs don't have. It drives me nuts that the OEs do not give you fuel pressure. Holley does not make any decisions based on fuel pressure, again, unless you set up an advanced table to do something with it. But it's nice that they just include it in the harness so that you can monitor it. Throttle position sensor, TPS. This is something that in my case I'm not going to use because I'm drive-by-wire, so I'm not going to clip this out or cut it or anything. I'll see if I can find a cap or something, or tie it back and tape it, heat shrink it, something like that. Gen 4 stuff has got a cam sensor on the front, so we got the cam sensor up front there. Just like TPS, idle air control valve, because it's not a drive-by-wire deal. I'm not going to use this. You don't use that with the drive-by-wire. What's really cool about these harnesses, and I know that some people are annoyed by the fact that all this stuff is here that you're not going to use, but what's really cool is it's extremely versatile. Like if you ever decided to put a cable-driven throttle body on it, or, I mean, heck, in my case, if I ever, and I'm not going to get rid of the Corvette, if I ever got rid of the Corvette, I could take this off and keep it. And the way I'm planning on installing it, it's all going to be plug and play. And I'll just put the factory ECU back on, and nobody will ever be the wiser that I was ever in there with anything other than the factory ECU. And then I can go run this on a drive-by cable setup, no problem. It's easy to do. Cam sensor, pretty self-explanatory. I think I already covered it actually. Coolant temp, really important for your EFI setups. So just keep that in mind that your coolant temp is really important, and so is manifold air temperature, MAT. Part of your fuel corrections is coolant temp, and part of your fuel calculations is manifold air temperature. So flow is calculated using pressure and temperature, and whenever we've got manifold pressure, manifold absolute pressure, the MAP sensor, plus the manifold temperature sensor, and we've got RPM and a volumetric efficiency table, we can calculate the correct amount of fuel to put in the cylinders. And if we keep going here, last but not least, our wideband. So this might look like a mess, but honestly guys, this is silly simple. I mean, this is crazy simple. I'm not gonna do it because I don't feel like having to deal with it, but like if I pulled the harness off the bed, the factory harness, all this stuff and more, where it plugs in, I think people get lost on the fact that these things only have these two little grounds right here. You literally have 3 total grounds to connect. 2 of them are already terminated, and 1 of them is not, and is this ground for the relay. That's it. There's no other grounds on this thing. It's extremely basic and extremely simple. And because there's no other grounds, it has no other references. If you look at your factory, setups, they've got all these different grounds running all these different places. They did that so that there would be plenty of redundancy. And these guys are so important. I can't stress this enough. You got to have good grounds in order for this to work. So when you guys are wiring up your own kits, take your time, be meticulous, make sure you get nice good grounds, make sure your connections are well made, make sure that all your pins, as you're going to connect stuff, make sure that all the pins are correct and fully seated, make sure that the locks are all placed on the back. I said it in the EFI video that bad data in, bad data out. Well, bad install means bad data. It's that simple. If you are looking at your data logs and you have these long periods of time whenever you don't get any data points, you got wiring problems. Like you got interference, you got wiring problems, you got bad grounds, you got whatever is going on. That's what it is. You need to go back and rewire the setup. So I am probably going to cut it off there because I've already been talking for way too long. Let me know what you think. In the comments about this setup. I'm going to go through and I'm going to try to record, document all of it best I can, and try to make it as exciting as I possibly can. I'm excited about it, obviously, and there's definitely a little more in the tank, so to speak. I got something up my sleeve. There's a reason that I needed a Holley setup to put on the bed, and I think you guys probably are kind of picking up what I'm putting down by this point, but it's going to be good. We're going to get the install done, and then I get to go ahead and start going through the handheld, how we're going to set up the handheld, the different things you can do with the handheld, how to connect your laptops, and just some basic tuning stuff, how to set up the tune in the laptop. I'm going to go through it 2 different ways. We're going to put the Wizard tune on, and actually, at the risk of my car, and I mean that very seriously, as long as the tune looks decent and it's not just like completely out to lunch, I'm going to show you guys something really cool. I'm going to put the Wizard tune in it, and I'm going to dyno it just like right out of the gate. Not going to give it any time to learn. I'm just going to load the Wizard tune. I'm going to run the Wizard on camera, and I'm going to peg the thing, and then we're going to look what kind of power it makes. And then I'm going to go back and put my tune up in it and see if I can make more power. That's going to be a real test of the tuner, right? So we'll see what it makes, and see how close the Holley setup is. So, all right, I'm going to cut it off there. As always, let me know if you got any questions, comments. Shoot me a PM on Facebook. Give me a call, shoot me an email. The email is tuning.gsp@gmail.com. And a quick shout out for any of you that actually made it this far. We cracked 100 subscribers last night, and I know that is an infancy for a YouTube channel, but I don't know. It seems like you guys kind of like the content. It seems like it seems to be useful. if it is, then that is awesome, and I really appreciate the support, and we'll just keep it rolling. Like we'll keep doing cool stuff, and whatever you guys want to see, we'll let it drive it. If I can fund it, I'll fund it, and if not, then we'll come up with some way to fund it. Right? We'll find a funder or find a sponsor. All right, that's enough for now. More to come.